Hi everybody, this is Julian from Arcee. You know, I'm a big fan of running small language models on CPU, and recently I've been working with Intel to optimize AFM-4.5B, our first foundation model for Intel platforms. So in this video, I'm going to show you how you can optimize this model using the Intel OpenVINO toolkit and deploy it on the latest generation of Intel Xeon processors. And I'll use an AWS instance for that. Okay, this should be fun. Let's get started. Before we dive into the demo, let's look at the building blocks we're going to use. So of course, we're going to need an Intel server, and I'm going to use the newly launched R8i instances on AWS. So, family names get crazier. So what is R8i? So R8i is Intel based, obviously, and it uses the latest generation of Intel chips, Intel Xeons. Okay, so you can call them Intel Xeon 6, or you can call them Granite Rapids. It's the same thing. But the important thing is it's the latest generation, and that matters a lot, as we will see, because those CPUs have dedicated instruction sets to accelerate AI inference. Okay, so you can use any Granite Rapids servers. In fact, you could use the previous generation as well. It would work. And you can use a real server or you can use a cloud server. It doesn't really matter. Okay. Um, those Granite Rapids servers on AWS at the moment are only available in the R family. And you may know that this means the memory optimized server, so high memory capacity servers. I remember that because R is probably for RAM. Well, that's what I like to believe. So these are way too much memory for our purpose, but that's the only option at the time of recording. I'm guessing we'll see C8i at some point, which are the compute optimized instances. And this will have less RAM, they'll be more cost effective, and this would be my go-to option. But for now, we'll use R8i, and I'll put the link to this nice blog post in the video description as usual. We'll need a model, obviously, and I'll use AFM-4.5B, which we've discussed quite a few times already. This is the model page on Hugging Face. Again, I'll add the link. Just for information, if you want to skip the model optimization process altogether and just deploy it, I've also added OpenVINO versions on Hugging Face as well. There's a 16-bit, 8-bit, and 4-bit model, so you can just clone the repo and load those if you prefer. But in the demo, I will go through the full process. Okay, and of course, we'll need the OpenVINO toolkit, which, as you probably know, is an Intel toolkit to optimize models for a wide range of Intel platforms, CPU, GPU, and even NPU for AI PC. So we'll do CPU this time around. Okay, and last but not least, we'll use Optimum-Intel, which is an open source library by Hugging Face that makes it really super easy to work with the Intel tools, right? So literally a one-liner, as you will see. Okay, so these are the building blocks. You'll find all the resources in the video description. Now let's get to work. In the interest of time, I've already launched the AWS instance. There's nothing special here. I'm running Ubuntu 24, so all the commands here will be Ubuntu, but if you prefer to run another Linux variant, that's not a problem, right? So we could go and ls cpu, and we'll see we are running this fancy Intel Xeon, which is actually the Granite Rapids generation. And if we look at the CPU flags, we'll see a whole collection of flags that are really super important for our use case. AVX512 with sub instruction sets, AMX, which is a matrix multiplication instruction set, and a few more. Okay, so all these are actually what will speed up AI inference on this instance. Okay, and this is actually R8 i4XL, and I've got 32 vCPUs, as you can see here. Okay, you can probably go a little lower if you want. I don't think we need 32. We'll see what kind of speed we get. But yeah, I'm pretty sure you could go even to maybe 8 vCPUs and still get okay performance. But this is the one I picked, kind of a middle of the road option here. All right. And again, in the interest of time, I've already installed Docker. If you don't know how to install Docker on Ubuntu, I will add the link. But I didn't think it was important to show you that. Just copy paste from the instructions, and this is what I have. Okay. So now we're ready to create our environment, start installing our tools, and optimize the model. Okay, let's do this. First, let's install some dependencies. We're not going to need much. I just want to make sure I have Git and the virtual environment in Python. I'll put a link to all those commands as well, so you can just copy paste. Nobody will complain I'm skipping steps this time. Let's keep everything organized. So how about creating this? Let's create a virtual environment, which is generally good practice. Okay. Let's just make sure we have the latest pip. All right. And now we can almost install everything with a single command, which is this one. Okay. Pip install Optimum-Intel with the OpenVINO dependency. Don't forget this one, because if you do, well, OpenVINO will not get installed and you'll see some errors. And we'll just install from directly from the Git repo, right? This guarantees you have the latest version. Optimum-Intel moves fairly quickly, so usually, you know, it's a better option to install from source. Okay. Okay. So after a minute or so, this is installed. We can check. We have what we need here. Optimum, and I guess OpenVINO is important. Okay, and yeah, this is the right version. AFM support was added in OpenVINO 2025.3 that just came out last week. So we should be good to go. Okay. The next thing we need to do is to make sure we can download the model from Hugging Face. Okay. So I've already obviously accepted the terms. So you need to accept that and you'll be able to download the model. Make sure you have a token. If you don't have one, you can create it in access tokens. Okay, a read-only token is all you need. Okay, store that somewhere safe. And now we should be able to log in to the Hugging Face hub. Okay, just copy your token here. We don't need a Git credential. Okay, so now we've logged into Hugging Face and we should be able to download the model. Right, so the next step is very simple. We're going to use Optimum-Intel and its nice CLI to download AFM and optimize it with OpenVINO. So here, all we have to do is Optimum CLI export OpenVINO, the model repo name, and the weight format that we want to use. So let's first optimize the model for 8-bit precision. Okay, so int 8, and this is simply the name of the local path where the optimized model will be saved. Okay, so let's just run this. We should see the model download, right? If this fails, it means your token is invalid or you didn't log in or something like that. Okay. But if you followed my steps, it should be okay. All right, so we downloaded the model. Now we're loading it, and in a few seconds, we'll see OpenVINO optimizing it to 8-bit. Okay, it's a fairly fast process. There we go. So we have 218 layers, and 100% of the layers are quantized to 8-bit precision. And we'll just save the model to that local path. Okay, and we can see the model here. Let's do the same for 4-bit. If you want to do that real quick, it's exactly the same process. Just say int 4. And if you want to 16-bit version, you just say FP16, but I'm not going to do that. Okay, so exactly the same process. We've already downloaded the model, of course, so we can skip that and quantize to 4 bits. Okay, and once we've done that, we'll write a small Python program and we'll load the model. Okay, so some layers are still in int 8 by default, and most of the layers are 4-bit. There are a ton of options for Optimum-Intel and OpenVINO in general, so we'll look at a few more later. But if you have, I would say, fancy quantization recipes, you can apply that. Okay, so let's just go and, yeah, let's go in this thing. Let's just make sure we have our environment. Okay, and now we're going to run a very simple test. Okay, test ov.py. And we're going to use the Optimum-Intel API to load the 8-bit model here and use the basically the transformers library from Hugging Face to go and predict. And the really nice thing about Optimum-Intel is it is extremely close to the vanilla transformers API. So if you're familiar with transformers, here we would say, with the vanilla model, we'd say auto model for causal LM. Here we just turn that into OV model for causal LM, and the rest of the code is exactly the same. You can use the pipeline, the Hugging Face pipeline, etc. Okay, so let's just go and try this. See if it works. So now we're loading the quantized model, and we should start predicting. Okay, so Arcee AI is an AI research and engineering firm, blah, 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 blah. Okay, so this works. We could just go and do the same thing with the 4-bit model, but let me bring that code up again. So as you can see, that's all there is to it. So if you want to integrate your model directly in the app, you don't want to run an inference server, this is how you could do it. If you want, again, the high-level Hugging Face API, you can use the pipeline. And there's also an OpenVINO API, which is a little bit different, which is available in Python and in C++. So go to the OpenVINO website, and they have some code snippets and some good examples in their repos as well. Okay, so that's the first way we can work with the models. Okay, so now, what if we want to deploy the model with a proper inference server? Can we do that? The answer is yes. OpenVINO comes with a proper inference server, which is called OpenVINO Model Server, or OVMS. And now I'm going to show you how we can set that up, configure the models for deployment with OVMS, and we'll go and deploy. Okay, so let me clean things up a little bit, and I'll be right back. Okay, let's look at OVMS. So OVMS obviously uses OpenVINO under the hood, and it needs a few config files for the inference server to be able to load models, etc. Okay, so we could write them manually, or we could just use the export script that comes with the OpenVINO Model Server. We will optimize the model once again, and in the process we'll also create the config file. So let me show you how to do everything in that single step. So first, let's clone the model server repo. Honestly, the only reason we need this is because we need the export script, which lives here. Okay, this one here. So we don't need to add the requirements here, because we've already installed OpenVINO. So you don't need to do anything here. Let's just create a directory to store the models and the config files, and this is what we'll pass to the inference server. Okay, and now in a very similar way as we've done before, we can run the export script. Okay, so export model.py, text generation, because this is a text generation model. You could export embeddings or image generation models, etc. The source model on Hugging Face is still this one. The model name we want to use locally is this. We'll quantize to 8-bit. We'll store the config file for OVMS in model/config.json. That'll be the repo path for all the models. I'm also adding two performance options, so to speak. So enable prefix caching, which, as the name implies, will cache the prefixes for your prompts. So that means if you want to, if you reuse existing prompts or some prompts start with the same tokens, this is already cached, and this is a fairly significant speed up. And we'll use 8-bit precision for the KV cache, which is not strictly necessary, but it saves RAM. Okay, so if you have a bigger model and you have a very large KV cache and you want to save memory on the host, instead of using 16-bit, you could use 8-bit. Okay. And of course, I want to convert this for CPU, right? The host CPU. So let's just run this. So of course, under the hood, it uses exactly what we've done before. So we're going to see that model conversion process once again. And if we look in the models directory that we created, okay, so of course we'll see the model itself, okay, and we'll see the config file. And you'll see why this is important. Okay, we save the config file. Here it is. So this is really the bare bones config file, which tells you, okay, if you want to work with model AFM-4.5B OV8, it's in that path. Again, there are a zillion options that you can add for optimization or monitoring, whatever. And go look at the OVMS documentation. But the cool thing is now if we add, let's say we want to add the 4-bit model as well, let's do that. So just change the model name and the weight format. Okay, everything else should be the same. We're going to convert the model, obviously. Okay, so it'll show up in a second. And the model will be added to the config file. So that means you could have lots of different models available at any time. You don't need to load a single model in the inference server. You can actually configure several models, and which could be completely different. Here, of course, I'm using two quantizations of the same model, but they could be very different models. And as long as they're defined in the config file, you can request them on demand, and they get loaded on demand. Okay, so now we have two models configured for our model server, which is exactly what we wanted. Okay, good. So now next step is, why don't we grab the OpenVINO Model Server, and well, it's a Docker image, so we just need to pull that Docker image. It's not big. Okay, less than 500 megs, so pretty good. And now we can just run the server. Okay, so Docker run on port 8000. We have a Docker volume here, okay, which is what we created. So this models directory that we see here, okay, is going to be mounted into the container at /models, mounted read-only because there's no reason to tweak anything. That's the Docker image name, again, some ports, and the location of the config path inside the container. So obviously /models/config. Okay, let's just run this. Okay, make sure you have OpenVINO Model Server 25.3 or higher. And we should see something like this, yes, which is good news. So AFM-4.5B int 8 is available. So that means the model is ready to be served. And we should see the same for, yes, int 4, okay? So if you see unavailable or some kind of error in here, basically it means, well, there's something wrong with your config file, or maybe the path is wrong, or maybe the model doesn't exist, or maybe it's corrupted, etc., etc. But yeah, if you see available, it means it's ready to be served. Okay, so now, how about running another example? We can try curl, why not? First, okay, so curl OVMS on port 8000. We use the OpenAI format here, which is fully supported by OVMS, so that's good. We can pass the model name. We don't need to pass a model key because it's irrelevant here. So just pass the name of the model. And this should be the name of the model in the config file, of course. Some additional parameters if you feel like it. And then there's the prompt. And let's see what happens here. Okay. So, well, we get an answer. Okay, so that worked. Okay, so as you can see, we can invoke this just like we would invoke any OpenAI model. Now let's just maybe use the OpenAI client with Python. So let's just pip install OpenAI. And let me grab my code here. All right, well, we've seen this a million times. Import the OpenAI client, point to the endpoint. So the OVMS endpoint, again, no API key needed. And we can do streaming inference this time with the 8-bit model. Okay, again, that's the model name in the config file. Streaming equal to true, and then a very simple function to decode the streaming answer. Okay, so let's try this one. All right, here we go. Okay, and yeah, this is pretty good. Okay, let's try a slightly more complicated question. How about my favorite question? It keeps me awake at night. And yeah, why don't we go for more tokens here? Okay, let's try this one. All right, off it goes. And you can see the speed is more than adequate. More than adequate. We're running on, I'm guessing, on all threads. Yes, we see that here, 32 threads. Okay, so we're actually using well, trying to use every single thread on the system, but obviously some of them are busy doing something else. So we could try fewer threads. That's actually an option we could set. But you can see here, this is already faster than I can read, right? So there you go. As you can see, it's really super easy to work with small language models in general, and AFM-4.5B in particular on Intel instances. We can see that even with a small instance of 4XL, we get already very nice speed. So for some use cases, this is really everything we need. We could run several models or several model variants even on the same machine. We're not limited by GPU RAM. There's much more host RAM than we'll ever need here. So we can just load models on demand and work with them. and without the need for GPU instances, which tend to be expensive and tend to be a single point of failure as well in your architecture, something that isn't really discussed. Maybe I should cover that at some point. So there you go. Nice little demo. Again, I'll put everything in the video description. I'll put all the commands that I use for setup. And I hope you liked it. Okay. Until next time, my friends, you know what to do. Keep rocking.